Hello everyone, I humbly present you with a math problem. Do your best, solve it, see what you get. What we're doing today is called evaluating expressions. And in particular, we're going to be evaluating expressions using something called the order of operations. But before we get into what that means, let's jump back to the problem that you just worked. We have 24 divided by 2 times 9 plus 3. So we look at what we should do first, and I think we would probably all agree that we need to do 9 plus 3 first. So 9 plus 3 is, of course, 12. And then we have the rest of this, 24 divided by 2. There are now two ways that we can do this. We can do the division first. 24 divided by 2 would be 12. And then 12 times 12 is, of course, 144. Or we could do the multiplication first. 2 times 12 would be 24. And then we would have 24 divided by 24, which is, of course, 1. So depending on what order we do these things in, we get different answers. That means it becomes incredibly important that we all decide to do them in the right order. But before we even get there, let's talk about what an expression is in another sense. An expression is really just a set of instructions used to find a number. So in this case, my instructions include dividing, adding, multiplying, things like that. When an expression doesn't contain a variable, like this one right here, which does not have a variable in it, we can do what's called evaluating the expression to find the number it describes. So when we did the calculation and reduced this to a single number, that process was called evaluating. And each instruction, remember I told you we had instructions. We were supposed to divide right here. We were supposed to multiply where these two were written right next to each other. We were supposed to add. Each one of those instructions is called an operation. So in order to evaluate an expression, we must do the operations in the right order, which is where this idea of the order of operations comes from. And here is the order of operations. You probably remember it best as PEMDAS, P-E-M-D-A-S. However, using that memory device can often lead to trouble with these last parts. Notice how I've written the M and the D and the A and the S. This is going to become very important here in just a second. So what those letters stand for? We've got parentheses and grouping functions. These are the things we do first. So this is where we start. If we see these things, we do them first. So parentheses obviously are things that look like this. And grouping functions, that would be things like fractions in particular. So if I've got some value over top of another value, that would be a fraction and is considered a grouping function. Next up, we would do exponents and roots. So exponents, remember, are those superscript values written like that. Roots look something like that. If you see either of those, we do those second. Now, for our particular lessons, we're not going to see a whole lot of those, but I want you to know where they fall in this. Next up is multiplication and division. Multiplication can appear using that cross as a dot or as two things written right next to each other. So all three of those forms are multiplication. Division can be written using that division symbol. Sometimes you'll see it written in a computer as a slash, although that's not very good because it can be a little ambiguous as to what you're supposed to do there. And we will see it most often written as a fraction. And then, of course, addition or subtraction is what we do last. So knowing this, we now know what order we can go in when evaluating these functions. And remember, evaluating just means finding the number they're equal to. So, again, keep this in mind. Let's jump through and now talk about each one of these individually and look at some examples of each in practice. So with parentheses and grouping functions, any operations, remember operations are multiplication, division, addition, subtraction, complete any operation in parentheses first. If you have a set of parentheses and there are multiple operations, then apply the order of operations inside those parentheses. If you have a fraction, do everything on top, everything on bottom, and then divide the result. So a good way of thinking about this is that a fraction bar makes everything in top in parentheses and everything on bottom in parentheses. So let's take a look at an example of this. So we have parentheses and grouping functions in this one. The first thing we're going to do is going to be 2 plus 5. And so we would write that over here. I'm just, in fact, going to rewrite the whole thing. 2 plus 5. And then what I'm going to do is I'm going to do everything in the parentheses first. 2 plus 5 is, of course, 7. 7 times 3 is 21. And that would be my answer. Now, something I want to point out that's a little interesting on this is that your calculators are actually set up to do the order of operations for you. So if you're looking at your TI-84 and you were to punch in those numbers exactly as they appear there, and I apologize, I can't get low enough to show you the 3, but if we put in 3 times, and then we use our parentheses, and type in 2 plus 5, your calculator actually knows the order of operations and will apply these correctly to give you the answer. That being said, don't use the calculator as a crutch. Actually do each step individually, and that's going to yield a much better result for you in the future. We can also look at one that's a little more complicated. This one now has a fraction bar. So what I'm going to do, I'm going to rewrite the problem. I always start off by doing that so that I have a clean copy to work with. And then what I can do is imagine that the top part and bottom part are in parentheses. So if that top part is in parentheses, I know I need to do that operation first. 2 times 5 would be 10. And then I do everything on bottom as if it were in parentheses. So 3 times 1 is 3. 5 minus 3 would be 2. And then I can do 10 divided by 2, and find that this is 5. Again, your calculator is designed to take the order of operations into account, but with fraction bars, you have to make sure to put the top part in parentheses, like that, and then the bottom part in parentheses as well. And it's perfectly acceptable to have multiple sets of parentheses. There's nothing wrong with that. And so if I write it out like this, my calculator will in fact give me a correct answer. But again, don't lean on this. It's better to do each part individually, write them out, and then just use the calculator for each individual step in between. Next up, after parentheses and grouping functions, are exponents and roots. For these, we'll go into more detail with them later in the course, but for right now, just use your calculator to do these. So for example, if I gave you something that you had to evaluate that looks like 3 squared, I would want you to just enter that into your calculator. I don't want you to try and do this in your head or by hand or anything of that nature. So all you're going to have to do is you'll enter in the 3, and then you want to look for this right here called a caret right above the division sign, and if you press that, the next thing that you type in will be your exponent. So this is now 3 raised to the 2nd power, also pronounced 3 squared, and this would be 9. So I can come back over here and say that this is going to be 9. Same thing with roots. If I'm asked to find the square root of something, say the square root of 9, I expect you to use your calculator for that. So to enter that in, we would type in the square root symbol, which is right over here. Anything you see written in blue, you can access by pressing the 2nd button first, and then the button where you see that blue label, and then we can type in our number, and the square root of 9 is just 3. So we can type that in There. Next up is going to be multiplication and division. We've already done all our parentheses or grouping functions. We've done our exponents. We've done our roots. We've done multiplication, or now we'll do multiplication and division. So there's something key to remember here. For multiplication and division, multiplication does not come first. Multiplication and division happen at the same time. So start on the left side of the problem, do the first multiplication or division problem that you see, and then keep moving to the right, doing each additional multiplication or division problem that you encounter. Next up is addition and subtraction, and it follows the same rule as multiplication and division. Addition and subtraction happen at the same time. Begin on the left, do the first addition or subtraction problem you see, and then move to the right, completing each additional problem. So let's take a look at that in practice. We are asked to evaluate 6 minus 7 plus 8. We know that addition and subtraction, which is all that we have in here, we don't have any parentheses, we don't have any exponents or roots, no multiplication or division, and we know that addition and subtraction happen from left to right, and we just do the first that we encounter. So the first addition or subtraction problem that we encounter is 6 minus 7. 6 minus 7 is negative 1. And so we just simplify that and bring it down and have plus 8 over here. If you are ever even slightly unsure, enter it into your calculator. Go ahead and type in 6 minus 7 and hit enter to get negative 1 if you are not sure. There is nothing wrong with that. Negative 1 plus 8, same thing. If you are even slightly uncomfortable with what that answer is, go ahead and plug it into your calculator. There's nothing wrong with doing that. So negative 1 plus 8 would in fact be 7, and that is our answer to this problem. We've evaluated, we've taken this whole expression and simplified it down into a number using the proper order of operations. We can do that here as well. Just as before, I'm going to start by rewriting my problem. And now I do everything in parentheses first. 4 minus 1 is going to be 3. Next, I'm going to evaluate any roots or exponents, and I see I have an exponent of 3 squared. So I'll type in 3. Remember, right above the division sign is where I find my exponent symbol. So 3 raised to the second power is 9. So now I rewrite this. I know that this is supposed to be 2 times whatever 3 squared is. So that's 2 times 9. And now I look for any multiplication or division. Well, there's multiplication, 2 times 9. So I have 5 plus 2 times 9, which is 18. And then 5 plus 18 would be 23. And I'm finished. I have evaluated. I took this expression, simplified it into a number, following the order of operations. Also, notice my work. I showed every single step through that. That is an expectation for you as well, that you would show every bit of your work as you go along on this. So to recap, the order of operations tells us how to evaluate an expression. Evaluating an expression means taking the whole thing with no variables and simplifying it down into a number. The first thing I do is anything in parentheses. So in this case, I would do 4 plus 2 first, and I would get 4 minus 2 plus 5 times 4 plus 2 would be 6. Next, I evaluate any grouping functions. Grouping functions would be things like this fraction bar, which puts everything on top in parentheses and everything on bottom in parentheses. So I know I need to do what's on top first. Since there are multiple things inside there, what I'm going to do is use the order of operations inside that set of parentheses. So there are no more parentheses with stuff in them inside the parentheses. There is multiplication. So I would do 5 plus 6, and I find 4 minus 2 plus 5 times 6 is 30, all of that over 8. I'm going to bring this over here so that I have more room to work. If this was on paper, I would expect you to keep going down. 4 minus 2 plus 30. Now I evaluate the addition and subtraction from left to right. 4 minus 2 is 2. So I get 2 plus 30 over 8. Again, I'm showing every single step. 2 plus 30 would be 32 over 8. Now there's nothing left to do in those parentheses, so I can divide. 32 divided by 8 would be 4, and that is evaluating because I'm down to a number. All right, practice this up, and good luck.